Here is an explanation for the answer to final exam question number 32, found on page 668 of Teach Yourself Electricity and Electronics, 5th edition. The question talks about 9 capacitors, all of them having an identical value, 45.00 picofarads. We connect them in a series parallel matrix, like that. What is the net capacitance? Well, first of all, we should remember that whenever we have a symmetrical matrix, 3 by 3, 4 by 4, 10 by 10, any kind of a symmetrical matrix of components, and if those components all have identical values, which they do in this case, then the net value of the entire matrix will be the same as the value of any one of the individual components. So we know right away that the answer to this question is A, as in alpha. If we want to get a little more technical about this, there are 2 ways to connect a series parallel matrix. We can connect the components in series and then connect the series combinations in parallel, as we've done here, or we can connect the components, the individual components in parallel, and then connect those parallel combinations in series. This diagram does not show it that way. However, let's just look at this and break it down. This particular series combination of 3 capacitors will turn out to have a net capacitance, let's call that C sub 1, of 15.00 picofarads, 1/3 of each of the individual values. Similarly, the center combination in series, considered all by itself, will have 15.00, and so will the lower 3, considered only by themselves. When we connect those in parallel, capacitances in parallel add, you can see that that'll turn out to be 45 picofarads. Now, if on the other hand we were to consider the parallel combinations, each parallel combination would have 45 picofarads because each parallel combination would have 45 times 3 picofarads. That would be 135 picofarads. Let's just imagine, without redrawing the whole diagram, that we connected the sets of capacitors in parallel and then connected those combinations in series. Each one of these 3 combinations would turn out to have 135 picofarads. 135, 135, 135. And then we would add those, we would combine them in series and end up with 135 divided by 3, again getting 45 picofarads. So the correct answer to this question number 32, found on page 668, is A, as in alpha.